In this video, we're going to talk about circles, their parts, and some theorems with circles. So here I have circle O, and we're going to identify as many vocabulary words as we can. So remember, a radius starts at the center and goes to a segment on the circle. We can think of it as kind of halfway across the circle. So OR would be a radius here. And something to keep in mind is that all radii of a circle are the same length. For example, not only is OR a radius, ON is a radius, and OM is a radius. So whatever the measurement of OR is, let's say it's 4, that's what ON would be, that's what OM would be as well. All radii within the same circle are congruent. A chord is a segment in a circle that doesn't pass through the center. So, for example, AQ would be a chord because it is a segment in the circle, but it doesn't pass through the center. MON would be a diameter of the circle because it's a chord that does pass through the center. A secant is a line that intersects the circle in two spots. So line L2 would be a secant to circle O because it intersects the circle at two spots. So that would be line AB, which is also line L2. Tangent to a circle is a line that intersects a circle at just one point. So over here, that would be at point T. So L1 would be a tangent only intersecting at point T. So I can write line T. I'll just write L1 for this one. Line 1. A major arc is an arc that's more than half of a circle. So more than 180 degrees. So a major arc here would be, from M, now I'm at 180 degrees to Q. So I would call that MTQ or MRQ or MNQ. I just need to put a letter in between to indicate that I'm not going here. That would be a minor arc, but that I'm going here the long way around. So that would be maybe arc MTQ. And let me put my arc symbol. And then a minor arc is an arc that is less than 180 degrees. So MQ, arc MQ, would be a minor arc because it's less than 180 degrees. A semicircle is exactly half of a circle. So MN would be a semicircle. So I'm going to put here arc MN. A central angle is an angle whose vertex is on the center of a circle. You can remember central angle, center of the circle. So angle ROM would be a central angle of the circle. And an inscribed angle of this circle, an inscribed angle is an angle whose vertex is on the actual circle, on the circumference of the circle. So angle QAB would be an inscribed angle of the circle. Now, central angles are equal to the measure of their intercepted arcs. Intercepted arcs are the arcs that the angle opens up to. So for example, if this arc was, let's say, 50, if that angle was, let's say, 50 degrees, the intercepted arc, Rn, would also be 50 degrees because this is a central angle. Inscribed angles are half the measurement of their intercepted arc. So for example, if this angle is 35 degrees, and once again, I just made that up, that's half of its intercepted arc of the arc that it opens up to. So the arc would then be 70 degrees because the intercepted angle is the inscribed angle is half of the intercepted arc. Here I just have another picture of what a central angle is. So here are two examples of central angles, and notice how their vertex is on the center of the circle in both of these examples. This would not be a central angle because its vertex is not on the center of the circle. Here's another visual for inscribed angles. Notice how this is an inscribed angle because its vertex is on the circumference of the circle. It's on the actual circle. And inscribed angles are half the measure of the intercepted arc. They're half the measure of the intercepted arc. Okay, so let's name the center of the circle. The center is point B. The center is a point. Let's name all radii. So AB is one radius, BC is another radius, and BD is a third radius of the circle. And remember, once again, all radii of a circle are congruent. The diameter here would be ABC, or you can just call it AC for short. Let's name all chords. So YC is a chord. If we just go from endpoint to endpoint, it's a segment. Technically, the diameter is a chord. It's just a special chord that goes through the center. So I'm also going to put the diameter because technically a diameter is a chord. It's just a special chord that goes through the center of the circle. Let's name the tangent to the circle. The tangent is the line that intersects the circle in one spot. So I'm going to call this line CE. So line CE is the line that's tangent to the circle. The secant intersects at two spots. So that would be line YC. Let's name the point of tangency. So the tangent to the circle intersects the circle at point C. And then it's asking, is BD congruent to BC? The answer is yes. They're both radii of the circle, and all radii of a circle are congruent. Moving along. Let's take a look at this example over here. Here we have circle O, and the measure of angle ABC is 24. What is the measure of angle AOC? First of all, angle ABC is an inscribed angle. Its vertex is on the circle, and that means it's half the measurement of its intercepted arc. The arc that angle ABC is intercepting is arc AC. So if this is 24, then the intercepted arc would be 48. And the angle that we're looking for, angle AOC, is a central angle. It's got its vertex on the center of the circle. So that means it would be equal to its intercepted arc because central angles are congruent to their intercepted arcs. Moving along over here, the next example, we have angle BAC is 70. Let's find the measure of arc AC. So first, this angle over here is an inscribed angle. It has its vertex on the circle, and inscribed angles are half of their intercepted arc. So if this angle is 70 degrees, the arc that it's intercepting, BC, would be 140 degrees. And I know from B to A, that's a semicircle, that's half a circle, so that would be 180. So from B to C is 140, then that means AC needs to be 40 degrees to make a total of 180 degrees. Let's take a look at the next example over here. Let's take a look at this question over here. So we're told that we have circle O, and then we have a bunch of chords in the circle. And we're told that the ratio of arc DF to FE to EG to GD is 5 to 2 to 1 to 7. So arc DF is 5x, arc FE is 2x, arc EG is x, and arc GD is 7x. So I can make an equation that says if I add up all of the arcs, they should give me a full circle, which is 360. So I have 15x is equal to 360. And now all I need to do is take my calculator and divide 360 by 15, and I have x is equal to 24. Now I can plug in and find the measurements. So this would be 5 times 24. Let me replace that with what it is. That would be 120. This would be 7 times 24. Let me replace it with what it actually is. That would be 168. That would be 24. And this would be 48. It says identify 2 inscribed angles that are congruent to each other and give their measure. So angle D is an inscribed angle. And notice how it opens up to arc FE. So the measurement of angle D, since it's an inscribed angle, would be half of its intercepted arc. So if its intercepted arc is 48, angle D would be 24. Notice how angle G is an inscribed angle, and it also opens up to arc FE. So if arc FE is 48, this angle would also be 24. So inscribed angles that intercept the same arc have to be congruent. And that's a theorem that we also have as well. Moving down over here, you can pause the video to read the question, but we have a tangent to the circle, and then we have a bunch of chords in circle O. And Sam decides to apply this theorem to the diagram. An angle inscribed in a semicircle is a right angle. Which angle is Sam referring to? Let's check out the choices. Angle A, OB. That's not an inscribed angle. That's a central angle because it has its vertex on point O. So that's not the one Sam's talking about. Angle B, AC. This is an inscribed angle, but it doesn't open up to 180 degrees to a semicircle. So that's not the one Sam's talking about. Angle DCB. That does open up to half of a circle. It connects to a diameter. So that is the answer choice that Sam is talking about. So whenever you have an inscribed angle that opens up to, that intercepts a semicircle, half of a circle, since this is 180, this would have to be a 90-degree right angle. We also have something called a radius tangent theorem. And what that says is that when a radius in a circle and a tangent to a circle intersect, a right angle is formed where they intersect. Let's apply that theorem to the following question. So we're told that AP is tangent to circle O at point A, OB 7, and BP is 18. So since I have a radius and a tangent that are meeting, I know that they form a right angle. So I know that I have a right triangle. I know that this is 7 plus 18. So I can find the side of my right triangle by adding the two parts together. And that would be 25. And remember, all radii of a circle are congruent. Not only is OB a radius of the circle, but so is OA. So it would be 7. And then we're just finding this leg of the right triangle. So since we have two sides of the right triangle and we just need to find a missing one, we can use Pythagorean theorem. So 7 squared plus b squared is equal to hypotenuse squared. So that is 49 plus b squared is equal to, let me do 25 squared, 625. Let me subtract 49. and then take the square root of both sides. Hopefully that works out nicely, and it does. B is equal to 24. So that's an example of how the radius tangent theorem is used. Anytime a radius of a circle and a tangent to a circle meet, they form a 90-degree angle. So it makes right triangles. We also have something called the two tangent theorem. And what that says is that when two tangents to a circle come out of the same external point, they have to be congruent to each other. Let's take a look at how that could be used in a question. So in the diagram below, circles X and Y have two tangents drawn to them from external point T. The points of tangency are C, A, S, and E. The ratio of TA to AC is 1 to 3. If TS is 24, find the length of SE. So keep in mind, two tangents from a circle that come from the same point are congruent. TA and TE are both tangent to circle Y, and they come out of the same point, so they need to be congruent. TC and TS are both tangent to circle X, and they both come out of the same point, so TC and TS need to be congruent as well. So if TS is 24, that means TC also has to have length 24. So that means using the ratio, the 1 to 3 ratio of TA to AC, both of the parts have to make 24. So that's 4x is equal to 24. So x is equal to 6. So if I plug in 6, 3 times 6 is 18. And that means SE also has to be 18. And if I just wanted to find the other pieces, 6 and 6. So SE has a length of 18. The last theorem I want to talk about in this video is how when you have two parallel chords in a circle, the arcs between them have to be congruent. So if I know that these chords are parallel, I know the arcs in between them need to be equal to each other. So I can make the equation 2x minus 20 is equal to x plus 20. That would be x is equal to 40. And then to find AB, I can just plug in. That would be 40 plus 20 equals to 60 degrees for arc AB. Another quick example. We're told that AC is parallel to WF, and this angle over here is 60 degrees. We need to find this arc. Since we have two parallel chords, the arcs in between those chords should be congruent to each other. Now, the 60-degree angle is an inscribed angle, so it's half of its intercepted arc. So if this is 60 degrees, the arc that it intercepts, AW, should be 120 degrees, making this one also 120 degrees. So together, those two arcs make 240 degrees. And since all the arcs of a circle, since AF is a diameter, all together from A to F should make 180 degrees. So if this piece is already 120, 180 minus 120 gives us 60 degrees. So arc AC should be 60 degrees. And why not do just one more? So we're told that chord DC is parallel to chord BA. So as soon as I see parallel chords, I know that the arcs in between them are congruent. They tell us that angle BCD is 30 degrees. Angle BCD is an inscribed angle, So it's half the measure of its intercepted arc. So if the angle's 30, the arc that it intercepts DB should be 60 degrees. And since we have those parallel chords, if this arc is 60 degrees, this one should also be 60 degrees. Then I know that central angle, AOC, should be congruent to its intercepted arc. So I know that this should be 60 degrees as well. Still not where I need to be. I need to find angle AOB. But I do know that from C to B, that's half of a circle, so that's 180 degrees. I already have the 60 degrees, so 180 minus 60 is 120 degrees. And AOB, let me just highlight that. AOB is a central angle that intercepts arc BA. So if arc BA is 120 degrees, the central angle that opens up to it should also be 120 degrees.